Today I am checking out this package which came from Elecro. This is something that they sent me to, they called it a review. I'm going to call it a product feature because I don't really do reviews so much, but regardless, as long as the box survived the trip, this should be interesting to look at. This is their Raspberry Pi Pico Advanced Kit. It comes with a Pi Pico, as you might expect. It comes with 32 sensor modules, a smart car kit, and 32 lessons for MicroPython programming language that use all of these sensor modules. I'm not sure if I'm going to go through every single thing that's in the box, but we will go through some of it. This little figure 8 here is going to be for an optical tracking thing for the smart car that they mentioned. Here is all the different modules that are in the kit, and there's quite a variety of them. And then there's a set of mechanical instructions for assembling the smart car. A lot of these things anybody who's had any sort of microcontroller kit will be familiar with, and I do have a video where I've gone through most of the common sensor modules. I'll put a link up there to it. But we can quickly go through what's in here. There's a whole bunch of male to female DuPont wires. There is what they call a LED traffic light, which is basically just 3 LEDs mounted in traffic light mode. What do we have here? We have an IR remote control and receiver. A bunch more DuPont cables, male to male this time. USB cable. What was this that I just dropped out? Ah, that's the Pi Pico itself. So what this is not Pi's traditional business. This is a microcontroller, not a single board computer. So it's more comparable to the boards in the Arduino world, except that it's got an incredibly powerful processor on it. You can program this thing in C++ just like you can with Arduino stuff, but it also can handle MicroPython, and that's what I'm going to be demonstrating today, and that's kind of what this kit and the instructions that come with it assume, so we will do that. So on the bottom of the board, it has all the GPIO labeled and the other pin functions labeled down here, which is very nice, but we will come back to that guy later. What else do we have? We have a potentiometer. We have some RFID stuff. That's kind of interesting. An RFID key fob, an RFID card, and of course the sensor module, which connects back to the microcontroller. This is a capacitive soil sensor. Got a separate video on working with those as well. Got 4 7-segment displays on a board. Clock and data, so that's probably going to be I2C that it talks. I'm not going to go into all the smallest modules, but some of these bigger ones are kind of nice to look at. This is a 2x16, I think it is, LCD module, and it's got the I2C backpack on it, so it only takes power ground and 2 data lines to talk to it. We have a joystick, which is basically 2 potentiometers, one in X, one in Y, and a push button for clicking down like that. Very common. This one calls itself a flame sensor. It senses both infrared and ultraviolet in the wavelengths that you normally would get from just a standard flame. We have a little set of fan blades. We have a standard little 9-gram microservo. This is a raindrop sensor or water sensor and a little interface board for it. This is a high current motor driver. Well, relatively high current anyway. High enough current for the motors that are included in the kit. There is 3 breadboards, 2 of that size and 1 tiny little one. There's a lot of stuff in here. We have a DC motor. We have an LCD, or is this TFT module? Again, I2C connections to interface with it. There's a little screwdriver. Oh, that's cute. Oh, and it's both Phillips and straight blade. Nice. I assume that is the right size for these. It is exactly the right size for those. Perfect. And what else do we have? We have a 4x4 matrix push buttons. Good. We have a whole bag of other sensors in here. I'm seeing a laser. I'm seeing a bunch of binary input type sensors, switches and things. I'm seeing an ultrasonic rangefinder. A couple of buzzers and beepers. All kinds of things. I'm going to link to the sale page, which lists every single one of these. If I went through every one of these, it would be a 20-minute video. And here we have the Smart Car kit. 2 wheels, 2 motors, a plexiglass base with protector on it, battery, caster wheel, hardware, odds and ends. So that's basically 2 separate starter kits in one. Let's just take a quick look at the website and see what other information we can find, because I didn't find any instructions in here other than the mechanical instructions for the car. So here it is on Elecro's website, currently selling for $36.09 American or $37.99 normally, with the Raspberry Pi $5 more, which is probably how you're going to want to get it if you're getting this as a starter kit, honestly. Anyway, here is all of the different modules all nicely lined up. Even just on the sale page, they've got quite a lot of information where all the connections are on the board. And you notice that a lot of these pins can be multifunction. I mean, the majority of them are general purpose input-output GP0 through GP 28, I think it is. 26, 27, 28, yeah. But most of those can do other things as well. And then they have several of the projects just laid out to demonstrate some of the various things it can do. So they keep talking about 32 detailed lessons. We'll scroll down and find that eventually. There's the general specs of the Pi Pico. And there is the listing of everything that's in the kit. I'll just scroll through this slowly, and you can pause where you want if you want to read it more carefully. There's the tutorial and a getting started. Oh, that's a zip file. Okay, and the tutorial is a PDF. Right. Well, let's check those out. So the PDF is an 89-page manual, and it has, again, all of the different project lessons that they suggest listed in it, all the way from good old Blink, all the way up to 4 different versions of the Smart Car. Okay. And again, the same information about the Pi Pico itself. And then let's just go into single page mode here. There, that makes it easier to read. So that is that same diagram we saw on the sale page. There's the mechanical dimensions of it. Right. So the Pi Pico doesn't necessarily come with MicroPython on it. I'm not sure what it comes with, but their first thing is to go to the Raspberry Pi webpage, download MicroPython binary file, basically, and drop it onto the Pi Pico that they include. Well, there's where that link takes you to the Raspberry Pi's MicroPython page. Drag and drop MicroPython. It's as easy as that. So you just grab the file. There it is. And while holding down this button marked Boot Select, plug it into USB into your computer. And then on your computer, there should pop up this new disk drive, which basically the Boot Select puts it into mass storage mode. So what we have on the Pi Pico already is this text file, which just identifies it as a Raspberry Pi RP2, and this index.html file, which takes you back to the Raspberry Pi Pico webpage. But to install MicroPython on it, it's just as easy as dragging the file that you downloaded into that drive. See, it goes there, and as soon as it's copied, the board reboots. It's no longer connected as a mass storage device. So that's got that installed. Yes, it's that easy. So the next step in the manual, it tells you to go to the Thonny website and download and install that. Thonny is essentially the Python IDE, the development environment for MicroPython. If you're used to Arduino, it's a similar idea to the Arduino IDE software. It's where you write your programs, it's where you upload your programs, and stuff like that. So I've already gone ahead and installed Thonny, and here it is. I've still got the board connected, and this command prompt right here is actually coming from the board. We've got our files over here, which is the same files I've got here. And this is the that zip file that I downloaded earlier. It's got all the lessons in it. It's got the code for all of the lessons in it. So I should be able to drag and drop that into there. No, I can't. Let's get lesson 1 from here, which, if I remember correctly, was the blink. Yeah, there it is. Onboard blinking light. So I'm not going to go through all of MicroPython. I did a video about MicroPython earlier, and I've forgotten most of what I learned for that video, but I'll link to it down below anyway, or there's a lot better MicroPython lessons out there. Anyway, what this is doing is it's basically importing the libraries that it needs, the pin and the time. It's setting pin 25, which happens to be the one that's connected to the built-in LED, as an output. And then we're just looping through here, blinking at 100 milliseconds at a time. And I think I'm going to change this to 500 milliseconds at a time. And then I will run that. And as you can see on the board, we have a blinking light. And then stop it from here. So that's just the absolute basics. And here is the lesson in the manual that goes with the same blink sketch. Pretty straightforward if you follow through the steps. And just looking through the lessons that they've got in here, it takes you from the most basic thing, blinking a built-in LED, up through using a breadboard, introduces LEDs, and sets you up to blink LEDs. Here is the script for that. I'm just going to spin through these very quickly. Actually, we can see the titles of them all here in the directory from that zip file. And I'm going to go into a couple of them a little bit more closely just to show what comes with it. The first bunch are just getting used to using some of the standard sensors that come with it, and using some of the LEDs, and there's a little laser output module on there, more LEDs, the output buzzer, servo. Let's look at that one. This one has the Python script with it, as you would expect, but it also has a library with it. It has the servo library with it, which is just more Python. But this one, you notice, calls that servo library. It's not a standard library that comes with the IDE. It's a separate library. And this zip file that we downloaded also contains all of those libraries that you would need. This is the access card, which is using the RFID. And again, it has 2 libraries that you need for that project. One of them is the library for the NFC module itself, and the other one is a servo library. So you don't even have to go hunting around for the libraries, because they are already in the lessons, in the individual lessons. I think we should put together one of the car examples, and I am going to do the bumper cars one, and I will load it from here just because it's easier. I could also drag and drop it, or I could use the open function. File, save as. I'll save it on the MicroPython device, and I am going to call this, okay, so this is a MicroPython thing. I could just call it bumper cars and it would go there. But if I name it main.py, then that will be the file that runs as soon as the thing powers itself up, and it will just keep running. So I'm going to do that. There it is on the MicroPython device. So I've got my wires connected up here, and I'm just going to put a different program on the Pi Pico, because initially I had put the bumper cars program on, but I think I'm just going to put the basic motor driver car program on there. So I've disconnected the power that goes down to the motor driver module. I've connected to the computer. I've got the DC motor program loaded up here, but you notice on the MicroPython device, it already has a main.py. So I'm just going to overwrite that. File, save as, MicroPython device, main.py. Okay, do I want to overwrite it? Yes. So now, this is the program that's running on it. And I'll just quickly go through it. It is using the pin function from the machine library, as almost everything does. It's using utime library, specifically the sleep function from within that. It's dividing up 4 pins, pin 10, 11, 12, 13 to go to the motor driver, and those are the ones that I have physically connected on the board. It sets up some variables, sets the pins to outputs, defines the motors, and then it, in the loop here, sends 4 variables to the motor. So of the 4 outputs to the motor drivers, there's basically 1 for each wire going to the motor. So it's setting the first motor wire 1 high, wire 2 low, the second motor wire 1 high, wire 2 low. So it'll go in one direction. It will sleep for 2 seconds, I assume, which means the motors will just keep doing their thing for 2 seconds. Then it reverses both of the motors, and the program doesn't do anything, so the motors just go in that direction. Then it switches one motor one direction, one motor the other direction, waits, switches the motors the other directions, waits, and then stops the motors, puts all 4 of the outputs to 0, and then it sleeps for a second. And then the loop just keeps looping around. At least that's what's supposed to happen. So with that, I think the only thing left to do is put some batteries in it and see what happens. I think I'm going to try it just sitting up off the bench a little bit here. I know what I forgot. I forgot to connect the power to the Pi Pico. Oops. There we go. Now let's see what happens. Forward for 2 seconds. Reverse for 2 seconds. Turns that direction for 2 seconds. Turns that direction for 2 seconds. And stops. And then repeats. Perfect. Let's put it down on the floor so we can actually see it do its thing. Alright, here we go. Backwards for 2 seconds, spin that way for 2 seconds, spin that way for 2 seconds, then it goes off that way. Well, that was fun. And to think that's only one of the projects that comes in this kit of parts. There's all kinds of stuff that you can do with this. And as I said, I'm going to link to the documentation and whatnot down below so you can see what all is available. But so all in all, this is, I think, a pretty good beginner kit for somebody who wants to get into microcontrollers and wants to try something different than just the Arduino that we've all been using for years and years and years. And MicroPython, if you're going to be starting to learn a language from scratch, would you want to use C++, which is what the Arduino is based on, or would you want to use MicroPython, which is designed to be easier to learn? It's maybe not quite as powerful a language. It maybe takes a little bit more processing power because it's an interpreted language rather than a compiled language, but that doesn't matter so much because this is a whole bunch more powerful microcontroller than any of the Arduino family. So I don't know. I think I could recommend this kit, even though, like I said, it wasn't supposed to be a review. It's definitely a kit that you get a lot of mileage out of. Anyways, thanks for watching. If you got any more questions or comments, leave those down below. There's going to be a bunch of links down there as well. Thanks for watching. I'll talk to you later.